Good morning or afternoon. Happy second day back from spring break. I hope you had a wonderful spring break. Right now, I need you to find your Unit 10 notes packet. This is the packet that says Unit 10 notes at the top. It's the one that we've been working in for our unit on circles, which we started before we left. It looks like this. Unit 10, Property of Circles. You should have this. It was given probably a week and a half before we got out for spring break. So it's not something that you got that last day. All right, also find your homework, classwork from last class. It was the inscribed angles. I am going to take this for a grade next class, so you need to make sure that you have that with you. And it looks like this. It says inscribed angles at the top. And it was a homework that we did in class. We're going to go over that in just a minute. Important note that you need to make is that we are going to have a quiz next class. This quiz will be on everything we've done up until this point. So the new stuff that you will learn today will not be on the quiz, but your circle basics, that is where we basically talked about defining different terms like a tangent, a secant, a chord, a diameter, radius, all of that stuff. The arcs and chords rules, we had a whole section on arcs and chords where we found the measurement of different arcs. We talked about chords and how that if the chords are congruent, the arcs are congruent, and several other rules like the diameter is the perpendicular bisector of a chord, that kind of thing. And then the inscribed angle rules, which is what we did the last class that we met and did new material. I'm going to go over that homework today, and then that will be included on the next quiz. You will have a quiz the class period after next class, which will be the 27th for you guys, and then your test will be the 29th. Of this month. So there will be a class period between these two where you will get a review. All right. So you might need to pause the video now. I'm not going to stop during the video, but when you are using the videos, you can pause them if you need to catch up and find your different things. Right now, I'm going to be going to the inscribed angles homework and go over some of those problems to remind you what we had just learned in the last class that we went over new material. So if you need to pause the video at any point to be able to find your stuff, gather your stuff, or anything like that, you can do that. All right, this homework was our classwork. We actually did this in class for the most part. This was your inscribed angles. This is the last thing we learned. The first part of this is just asking if each angle is an inscribed angle, and if it is, name the angle and its intercepted arc. For something to be an inscribed angle, its vertex has to be on the circle. That's what makes it an inscribed angle. And this one does have a vertex on the circle. If I was to name this angle, I would name it BAC. So angle BAC is an inscribed angle. Its intercepted arc is this arc that is between the two sides of the angle, which would be arc BC. The second one asks if this is an inscribed angle, and if you look at the vertex is not on the circle, so it's definitely not an inscribed angle. So that one is just no. On this one, you're asked if this is an inscribed angle, and it is. The vertex is on the circle. You would name it VXW, and that intercepted arc would be VW. And number 4 is no. That is a central angle. It is a type of angle that we have talked about in the past, but it is not inscribed. A central angle is the measurement of a central angle is the same as the measurement of its arc. Number 5 through 8, you were asked to find the measure of the arc or angle indicated. Again, what we talked about last class is that the measurement of the angle is 1/2 the measurement of its intercepted arc. So if the arc is 80 degrees, the angle would be 40. Here, if the angle is 42, the arc would be twice that, because this is the half. The twice would be WV, which would be 84. Number 7, you were asked to find this piece between P and D. We do not have the angle measure for that piece, but what I do have is the angle measure for this angle at point E, FEP. P is 35 degrees. Well, if I look at the arc that this intercepts, it intercepts this piece of the arc right there between F and P, which if I double the angle, because the angle is half of the arc, that would be a 70-degree arc. Well, if I look at the whole half of a circle, what is the measurement of a half circle? Well, that's a semicircle, which would be 180 degrees. So if these two together would be 180, well, if I take out the 70, I could find this piece by subtracting 180 minus 70, which is 110 degrees. The next part of this, number 8, you were asked to find this arc between D and C, the arc CD. Well, if I look at the angle that goes with this intercepted arc would go with the angle right here at B, and we do not have that measurement. But what I do have is a triangle, and we know that the triangles all add up to be, that's right, 180 degrees. So if I take 49 and 70 out of 180, that will leave 61 degrees for this arc, which would mean that for that angle, which would mean that the arc is twice that, which is 122 degrees. Okay. Moving on, number 9 is a really good problem. Let me zoom in just a little bit there so we can see this really well. But it takes a little bit of working and maneuvering to get to the correct measurements. The one I'm looking for is right here at FV. That arc does not have an angle measure that goes with it, but I do have this angle, 119 degrees, would give me this whole arc FGH. So if I double that 119 times 2 is 238. Well, if I look at what I have left here, I know that this piece of that arc from G to H is 168 degrees. The whole thing from F to G to H is 238. So if I subtract these two, that's going to give me what's left right here to be the FG part of that arc, which is 70 degrees. 238 minus 168 is 70. Well, and if I look at this angle, the 65-degree angle, the arc that includes both of those is the arc from V to G right here, this arc. Well, 65 times 2 is 130. That gives me this whole piece. Well, if I only need the yellow part, then I could take out the blue part that I found using this other side over here and subtract those and get that this yellow part is 130 minus 70, which is 60 degrees. Again, that problem is a little bit complicated, but it gets you there if you look at the different pieces. Another one that I wanted to look at is number 11. If you remember that with our inscribed polygons, the opposite angles are supplementary. So if this one is 110, the other one is 180 minus 110, which will give you 70. And then if I look at the arc that this intercepts, it intercepts this arc right here, which are the two pieces, 50 and 30x. If I multiply this by 2, that tells me that that yellow arc that I just highlighted is 140 degrees. Well, then I can set up an equation with the 30x plus 50, and it equals 140 because those two added together would equal 140. Subtract this, subtract 50, divide by 30, you get x equals 3. It's kind of a similar problem with number 12. If I know that this angle is half of that measurement, if I take 192 and divide it in half, you get 96. So that would make that angle 96 degrees. So I could set up an equation, 31x plus 3 equals 96, and solve that. Another problem that I was going to look at is this number 13. What I have here are these two measurements, the 13x minus 10 and the 7x minus 10. You are asked to find this angle NLM. Well, if I can see that the arc that goes with that is the 7x minus 10, if I can find the x, I can plug it in to find that angle. If I look at these two, they are half of that circle. So that means that I can add them together, 13x minus 10 plus 7x minus 10, and set them equal to half of a circle, which is 180 degrees. When you solve this, you get that 20x minus 20 equals 180. Add 20, you get 20x equals 200, and divide by 20, you get x equals 10. I'm going to plug that in to this arc. Remember that I'm looking for this angle measure for the NLM. So I'm looking for this angle right here. So if I look at the intercepted arc, which is 7x minus 10, I'm going to plug that in. 7 times 10 minus 10, which is 60 degrees. The angle is half of that, so the angle measure for NLM is 30 degrees because it's half of its intercepted arc. You would do something similar with number 14. These two are angles in an inscribed polygon, which means they're supplementary. So I would add them together, 21x minus 2 plus 38x plus 5 equals 180. Again, they're supplementary. You solve that all the way down, you would add the 21x and the 38x, the negative 2 and the 5. You should get that x equals 3. And then you plug it in. You're trying to find the arc measure FGH right here. So if I plug it into this angle, which goes with that arc, you get that angle is 119 degrees, which would make the arc 238 because it is twice that. So you can double check those when you get that. I will check this homework. You do need to finish the rest of it. 15 and 16, leave those off. You do have to solve a system of equations to get that, and we're not going to go there. You do need to finish this homework. Make sure it is completely finished, and I will check it and give you a grade on that next class. You need to watch the next video to fill in your notes.